Talk with David Tupper, and him speaking on behalf of himself and Chris Buchanan. They'll be talking about the lithological and structural controls for gold mineralization at the North Lake and Greywacke North gold deposits.
Thank you very much. Thanks to the survey for inviting us here to talk about our projects in Saskatchewan. We're going to be talking about lithological and structural controls of gold mineralization at three of our project areas, the Greywacke North Lake, and Point deposits. This is our forward-looking statements, and you're more than welcome to read that at your leisure at another time. The Mass Gold is formerly called Mass Area. It has a fairly seasoned group of people. You'll recognize some names with Ron Metallurgical, Dale Walster, Rod Spooner, who spent a lot of time here in Saskatchewan doing exactly what we're doing here. We're actually breaking up our talk, and Chris is going to take the second part to talk in more detail about the structure. I'm going to cover an overview of Mass Gold's projects and a brief discussion of our near-term objectives. I don't really need to cover this too far. Ralph went into this in great detail and outlining this is a good place to look for gold, basically, the CB, the Snow Lake area, and the Lynn Lake area. Mass Gold has fairly significant property holdings in the area with 53,000 hectares and 5 properties strategically positioned along the Larange and Kissimmee domain boundary. We have been as a group active in the area since the 1990s. Key properties in this are the Preview North property and the Greywacke properties, which is subject to a joint venture with Golden Band Resources, of which we're the operator. I'm not going to get into this too far. This is the history, exploration history on these 3 areas. The key about this is highlighted in yellow, where there's a significant gap in the work that was done. There's SMDC Cameco, went into all 3 of these areas and drilled significant numbers of holes, 43 to 50 holes in various areas, but basically that 1990 to 2010 kind of gap of work, not much happened. The Point deposit, basically 28 years of very little work being undertaken. We've come back in there in this past year with $1 million of exploration work. I have to say thank you to the Saskatchewan Ministry for TMX-V assistance in that. But work this year has included a drill program in the winter in January, February, March, with 10 holes at North Lake and 13 at Point. Our work has included a recent program of structural mapping and surface channel sampling. We've initiated water quality baseline, so both of those at North Lake and Point. In addition, we've initiated metallurgical testing, which is partially complete at North Lake on flotation, sanitation, and gravity work. And we have just started work on core rejects for Point. North Lake, we have done some prospecting to the north, and then Greywacke North, with just a preliminary scoping work leading towards a planned PEA. I'm not going to go into a lot of the geology detail on our projects, but just to give you an overview of what we're doing. So, Greywacke property hosts the Greywacke North deposit, as we just heard. It's a high-grade, near-surface gold deposit with near-term production potential. 43101, the environmental work is pretty much fully complete. It was done in 2015. It is road accessible. We definitely have some potential for working on additional resources there. The Greywacke deposit itself, as it stands right now, was roughly 80,000 ounces at almost 10 grams, and then a 7 gram inferred resource of about 15,000 ounces. It's very amenable to gravity processing with a cyanide leaching bringing it up to 94%, which was done as a batch milling project work at the Joe mill when it was operating. Gold in the belt occurs in a free state with -400 to -200 mesh particles, very rarely getting coarser than 70 microns. It's generally within and bordering strain-free feldspar and biotite, rarely underground with sulfides. There is a sulfide association of pyrite and various other sulfides, including moly. It's hosted in quartz plagioclase, muscovite, biotite schist, which are generally BRNets and golanoids. The pyrite magnetite zones are coplanar with the axial epsilon folding. This is just an overview extending from the Greywacke North deposit on the right there, and the test pit from the batch milling shown there. But it shows 700 meters of strike length for exploration work ongoing. There's roughly 10 holes in the limestone that have, with surface channel samplings up to 28 grams, both in and Greywacke South, largely looking at gossinous aeronites. This is an older map just showing basic geology and the interpretation at this time of all of these being in sediment volcanic sequences. You can see North Lake and point to the south there, they're roughly about 5 kilometers apart. The North Lake deposit is an outcropping, low-grade bulk tonnage gold deposit with excellent preliminary metallurgical characteristics. Gold associated with shaded quartz pyrite veins hosted in a hematitic fine hardwood sandstone. There's rare visible gold typically found with a serious typo there, fluorite vein salvages. The metallurgical results preliminary up to 89% by flotation and 97 to 99% by cyanidation. This, the map on the left, the red bars on the drill traces shows the +1 gram intervals in the recent drilling. There are 10 holes drilled there. What's significant here is we have multiple wide zones of near surface continuous 1 gram gold, which we're finding is quite significant to creating a good base for a low-grade deposit. Perhaps we're not going to mine 1 gram, but it is an indicator of gold. What's interesting is the range of results has no serious peaks that are carrying those grades. But you can see in the hole 46, 62 meters of gram, followed right on the heels by 29 meters of gram, which is still fairly significant amount of gold. There's a trace of the deposit based on 1988 work, and this section being the same, but it does show how the gold does associate with the sheeted quartz vein, quartz pyrite veins. I should note at this point that the pyrite typically in the whole area is less than 0.5%. It's very low sulfide content. Coming back to the same image, but again, just showing fairly simple geology to the degree, conglomerate on top, a large arc-host package, a football, Mayfield volcanics, but this shows those broad zones of mineralization again. An example of drilling from there, so this is hole 45 with showing an 18-meter interval of 1.66 grams per ton gold over a larger interval of 1.2 or 38 meters. And you can see the grades drop off significantly as you fall into the football volcanics. The Point deposit 5 kilometers to the south, it's an advanced exploration target exhibiting multiple sheeted zones of high-grade gold. The gold is associated with minor pyrite in sheared, irregular, and discontinuous, another typo, quartz veins, another typo. Anyway, successfully confirmed results from our drilling this year. We had to follow up on SMDC because all the core was destroyed in a fire. But this is a 14 gram interval of 7 meters in calc-silicate altered volcanics is how it's been logged. You can see that's carried by a 69 gram per ton interval over a meter, followed by a 17 gram per ton interval over a meter again. This is a pretty colored slide, but you can see from the one on the bottom that what we found here in 3 holes were rocks very similar to what we have at North Lake, these pinkish arkoses, and over quite significant widths in the point deposit. The grades were not as significant as 1.7 grams over 6 meters in the top off, but it has the appearance of being a much more altered and silicified version of the North Lake arkose. Quickly, I'm going to just talk about what our plans are long term, or in the longer term. We're working towards, because we have a resource at Greywacke, to pursue a near-term gravity production at Greywacke and use that production to assist us in financing work on the Preview North property, which would include continued exploration and development of the North Lake bulk tonnage target, and where material could be commingled with potential high grade from satellite occurrences within about a 10-kilometer radius around that point being one of those. Anyway, I'm going to turn this over to Chris to give you a little more detail about that.
Thank you, Dave. Dave asked me to talk about some mapping that we did earlier this fall in late October. And I went in and worked on the North Lake deposit for a bit. So this is the current regional map in the area, and you can see North Lake is kind of in the middle of it, and it's shown to be on the eastern limb of the regional Hagen Lake Synform. And in this map, it's shown as being hosted in an aplite unit at the margin of a leucogranite in the core of the fold. And regionally, the footwall rocks of the deposit have been mapped as a porphyritic diorite. Over time, these rocks have been mapped as meta-arkoses, rhyolites, the ever-popular felsite, and currently aplite. This map is the current map that we're working on based on this fall's work, and it's been modified off of a map that Thomas published in about 1990. So it's a succession of tightly folded, steeply northwest dipping supercrustal rocks. In the footwall, you have strongly attenuated, interleaved, intermediate volcaniclastics, and mafic intrusive rocks. And most commonly, the rocks are trachytic volcanic rocks. That central light green unit is a trachytic volcanic unit. In the hanging wall, which are the host rocks to the North Lake deposit, which you can see highlighted in red just to the west of the lake. It's a sedimentary succession of very fine-grained pink meta-arkose, pebble conglomerates, and gray polymictic cobble conglomerates. The youngest rocks on the property are a series of pegmatite dikes, and they're almost ubiquitous across the property. Just south of the deposit, there's a broad zone. That's not one pegmatite dike. The dikes are only about 1 to 2 meters thick, but there's probably 4 or 5 dikes within that zone south of the deposit. And within that zone, the dikes appear to be coming in on a more brittle fault system, and we quite often see, as you get closer to the margins of the dikes, you see the foliation get rotated and dragged into those younger faults. So this is a schematic stratigraphic column. All of these rocks would now be grouped in with the Mullick Lake assemblage. And I'm just going to show some pictures quickly of what these different rocks look like and why we're going with a metasedimentary package. So in the footwall with the volcanic units, these are vaguely resemble deformed pillows with abundant plagioclase phenocrysts forming a trachytic texture. And this forms the bulk of that light green unit that we saw in the field, or in the last pictures. This is a different outcrop location, a more massive trachytic volcanic unit. And that's commonly what you see in the field is something that looks like this. And we also see fine-grained, layered, foliated, strongly foliated volcanic sequences in there. Towards the structural top of the footwall rocks, we see quartz pebble conglomerates as well in a volcaniclastic unit right near the contact. I didn't take a picture of it though, apparently. So these are the host rocks. This is the very fine-grained meta-arkose. It's pink due to the amount of hematite in it, which is generally increased in intensity in the vicinity of the quartz veins. And you can see one of what we're calling the sheeted quartz veins in the central portion of that picture. So this is the polymictic Kalba conglomerate that lies right above the host rocks, the lower meta-arkose. And you can see that it's a polymictic conglomerate. I've called them cobbles, but they're strongly attenuated. The ratios are in the order of 14 to 1 for the most part. And you can see that locally in the bottom left corner of the outcrop, there's, the clasts have been folded and dismembered as well as they've been transposed into the foliation. For us, this was kind of a key outcrop to decide that this was a metasedimentary package forming unconformably on top of the host rocks. The conglomerate grades, it's a gradational contact into an upper unit that's a pebbly arkose. It might be a bit hard to see, but where the circle is at the bottom of the photograph, those are flattened pebbles, and they grade upwards into a fine-grained arkose portion of it. That's about a 30 centimeter package. In that particular outcrop, you see it in a number of different places. And then this unit is unconformably overlain by another conglomerate. It's not as polymictic as the first conglomerate, but you can see where I've circled a couple of the clasts. It didn't take a very good photo. So these are how we see the rocks, the host rocks at the North Lake deposit. So the structural controls in the deposit, the succession is folded into tight isoclinal folds. At the deposit, it's a doubly plunging syncline. So at the south end of the deposit, it's plunging moderately to steeply to the north-northwest. And at the north end of the deposit, where you see a series of parasitic folds, it's plunging to the southwest. Then we're going to go in and look a little more closely at the core of those folds to the north of the deposit. This is a quartz pebble bed that's been parasitically folded right in the hinge zone of the fold. And you can see that it's strongly transposed and it's been dismembered. But you see these quartz pebble beds all through the pebble arkose in that area. So the quartz veins within the deposit, they form three main populations. There's the sheeted vein population, and that's labeled A in the first photograph. There's a set of oblique veins that are fairly common throughout the deposit area, and they form about a 15-degree angle to the sheeted veins. And it's consistently like what you see there. And they formed at the same time, mutually cross-cutting relationships on those veins. And then on the third photo there, you can just see the red line is highlighting a tension vein array. And you see tension veins all through these rocks, both north and south of the deposit. And they're consistently cross-cut the sheeted vein system and have a dextral offset along them. So on the stereo net, you can see the three lines represent the average orientations of those vein sets. And I'm interpreting these to be a conjugate vein system in a sinistral shear zone. That's a brittle ductile shear zone. And we think it's forming preferentially on the fine-grained arkose as a competency contrast with the footwall volcanic rocks. And then gold within these veins typically occurs along the selvage with chlorite. And this is an example of the gold. I don't know if you can see it in the circle on the right picture. And of course, this countermands my last slide. It shows you a grain of gold right in the middle of the quartz vein with no chlorite. But this vein is a bit different. It's at a high angle to the foliation. This came out a piece of core that was recovered from casing, so it wasn't actually included in the core box. But you can see that the vein formed late deformation. It's lightly crenulated by the foliation, which is a regional, I should have said earlier, regional axial planar to the fold at North Lake. That's pretty much what we have right now in terms of our developing understanding of this. Mass will take this information, our understanding of the quartz veins and the fold orientations, and incorporate that into the ongoing resource calculation. And it'll provide us hopefully with new exploration targets next year that can be followed up on. So Mass would like to thank the government of Saskatchewan for their support and their relationship with the Lac La Ronge Indian bands and various support people that have worked on the project over the last year. And also would like to thank Megan, the regional geologist in La Ronge, for coming out and spending a great day in the field looking at these rocks with us and helping us to come to some decisions on that conglomerate. And that's everything that I have for you.